Hello and welcome. Today we'll pick up right where we left off by adding a second component here called collage, so we can drag and drop our Flickr photos over to it. Now, it's going to look very similar to the Flickr component, so hold on to your horses. I'm just going to copy it really quickly here so we have a template to work with. And here we go. Okay, that should do it. Now, this is basically the same component, just missing this term changed, and we've renamed results to photos. It's just going to map the photos and show them here. And we've done a little bit of CSS to have the collage show the dotted line in the template beforehand. So, now we must implement drag and drop. And the way to do so, it's not very to do with the functional paradigm. We're going to quickly run through this because it's more important to our app and we just need to get through it. So let's give this a shot. We are just going to make this image draggable, true. And we'll say on drag start, we're going to make a drag start function. And all we have to do here is set the data transfer object. So it's just going to mess with the event here. It's a state event change. And instead of taking the event and grabbing the property, I like to deconstruct it. So we have a data transfer object off of the E, we'll call it DT. So let's go ahead and use that in here. And all we have to do is set data text to an SRC. And this SRC will come off of the current target, we'll call T. So this merely pulls the SRC off of the target, sets the text on the data transfer object, and we'll be able to extract this SRC in the drop zone so we know what photo it is. Okay, let's go ahead and update our collage to be a drop zone. And this is easy. We just need to tell the collage on drop. We'll come back to this dot on drop, but it needs an on drop function. And then on drop over, on drag over. I never remember this. And this is really just prevent default. And this prevent default here is really a helpful, reusable function. So why don't we extract that into a prevent default. It takes an E, and it just says e.prevent default. It's nice and easy. And that way, we won't have to write specific methods for this. We can say event to state event here. And again, we're not in the state monad. We're just writing a comment for our own good here. It's not actually returning anything at all. Okay, so on drop is going to be fairly simple. All we have to do is deconstruct that event again. Just get a data transfer object. We'll call it DT. And this is a function from event to, it will be a state change of photos. We want to update our photos. And to do that, we'll call this .update photos. And we need a new array of photos here. So what we'll do is grab the SRC off of the data transfer object. We'll do get data text. Remember, we set the data text to that SRC, so it comes right back out over here on the other side. And we can say, why not append the SRC onto this .state.photos. So it just makes a new array with the SRC included, and we update the state here. Now we need append from Lambda. Here we are, Lambda. And let's go give it a shot. There we are, just write llama. We come back with some beautiful llamas here. We can drag this one here, yep, and we can drag that one. We can drag that one. And you can see here, oh, that looks funny. What you can see here is they always put it in the top left when we drag on top, but it is working. Now we need to add the coordinates next. So let's go ahead and do that. Now this is where things start to get a little interesting because we've just been using URLs everywhere and we want to bundle some coordinates up with our URLs to make a data type of photo, which is the combination of both the SRC and the coordinates. So we'll use a tool called Daggy to update our model and bring in this new concept of a photo. So let's bring in Daggy. And this is just a tool to make tagged constructors. It's basically making a photo object, but the constructor doesn't need new, and it gives us some helpful tools to know if we've done everything correctly and we can pattern match and such. Daggy.tagged SRC, X, and Y. Now, this is just going to return us a type of SRC, which is a URL, and we've got an X, which is a number. Actually, scratch that. Let's call it a point. We'll make a little type alias here. Point is a number. There we are. So X is a point and Y is a point. And this will be a nice little photo object. And it'd be good to make a helper function that just turns a URL into one of these photos because we are just getting URLs back from Flickr, and we want to pull this into our own model as soon as possible and work with our data and not have to deal with different data types. So let's go ahead and make a new photo function. It simply it takes a URL and returns a photo of the URL, and let's start with X is 0 and Y is 0. There we go. And we can say this new photo is simply a URL function from URL to photo. And that's nice because we have, in fact, a bunch of URLs here. So we'll have to refactor some things to work with photos from now on. We want to work with an array of photo, and this will return us an array of photo here. And instead of calling it extract URLs anymore, how about we'll call it toPhoto. toPhoto map toPhoto. And this URL here will be exactly what we feed into new photo. to receive a photo because we have a function from URL to photo. So just like that, we take our URL and pass it in a new photo and we get an array of photos. Now we still have to go back to our Flickr component and update URL to photo. And just down here, instead of taking srcs alone, we'll take photos, call it p, and grab the src off that. And that should be all that's necessary to be working with photos. And what I'd like to do is now go back to our collage and attack the problem of the coordinates. Now, we know that we can get the client X off the event and the client Y off the event, and that'll give us the X and Y coordinates, the position of our mouse when we drop the photo. But what it doesn't do is give us our offset calculation from how far down the page is scrolled to our current element. And to get the offset, we'll say current target, which happens to be our collage here. And with that, we can say offset is our current target T, get bounding client rect dot top. If you want to see how this works here, we could say give me my collage, and if I get bounding client rect dot top, it gives me 210, but when I scroll up here, it gives me 308. So this is an impure function, but a useful one at that. Now, so since we're able to do impure things in our component here, we'll just call this here, and that lets us make a new photo here. Photo is our photo with the src, the x from the client x, and y minus the offset. There we are. We're going to add the photo to the array of photos, which kind of transforms all of these into photos as well. Get these srcs, and let's go update the type signature so we're not lost. And we have to actually use the coordinates here. Oh, I must pull in the photo constructor from our model. Don't forget to export the photo down here. There we are. Now, to use these coordinates, we can simply set the style. Top will be our y, and left will be our x. Now, this lends itself to an isomorphism, or we can say this object is isomorphic to the coordinates. And we could write a function from coordinates to style. Does anybody here know what isomorphic is?
Isomorphism, when the same code runs on the client and the server.
Wrong. Two objects are isomorphic if they satisfy this equation. Compose to and from is equal to identity. So if we have our chords object, we can turn it right into a style object. And if we have a style object, we can come back and turn it into a chords object. This is the nature of an isomorphism. It's the same information, different shape. We can go to and fro without losing anything. Now, another example would be taking a string and turning it into an array of characters. And we can go from the string to the characters and right back to the string. So getting back to our equation, going from and to and from should both equal identity, depending on where you start from. And we can prove this. Champ goes into to chars, and then from chars, and it equals champ again. And if we start the other way, it is also equal to identity. Now, you can do some useful things with this. We can run any array method on a string if we just convert it and convert it back afterwards. So we can take the first two characters with take, which is an array method, not a string method. In our application, what would be a useful isomorphism could be taking a photo into a style itself. So instead of using an image, we could use a div with a background image, and we could turn our entire photo into style to go onto the screen, and then we could take it right back off the screen and turn it back into a photo and not lose any information. We won't be using this in our application yet, well, at least not today anyhow, but it is good to know that it's there. It's a useful technique. Moving forward, now that we have our style, let's go ahead and give it a try. So we'll search for monkey. And we end up with some monkeys here. We could bring in the little, there we are. We'll just drag and drop them into their position, and they work just fine. These cute little monkeys are holding their spot. This one has a little, oh, it's so cute. Okay, now, with these, the next feature I'd like to implement is actually moving them within the collage, so we can change their position. We can drag it from the Flickr part down to the collage, but not around the collage itself. So let's go ahead and implement drag and drop for this image, and since it's the same thing, I'm going to go ahead and fly through, extracting out a component we'll call drag image, so we can share this component. Alright, that should be it. All we've done is extract this image over here to drag image. We've mixed in extra properties and given it the drag star to set the src here so we can share that behavior. So here's Flickr, and we go back to our collage, and it's also using drag image. So, and it keeps this style. So now we can drag it around, but we have this problem of on drop, because now it's not just going to append it every time, that will just duplicate all our photos. So what we'd like to do is actually replace photo if it is found, otherwise we'll append it. So let's go ahead and make a little model function called replace photo here, replace photo, and let's go over to our model, down to export replace photo. Now, let's start to flex our functional muscles here. So we've got replace photo is going to be a function from photo an array of photos, and it's going to return a new array of photos to be updated. And where to begin? Well, let's go ahead and say it's going to be carried. So taking our P and our P's, our photo and photos, and let's do a composition here. Don't forget to bring in our curry. Now, what we'd like to do is start out with an index, because we want to know if this photo is included in the photo, so we get the index of that photo. So let's say index of photo. And once we have the index of the photo, what shall we do? Well, we will probably remove it from the index. So we'll keep our index placeholder here. We're going to remove one element from our P's. There we are. So it will remove whatever index 1 P's. Now, one thing I don't like is I'm going to have to do an if-else check every time, and it's going to have to compare against -1, and I don't like the way that index of works. So what I'd like to do is return a maybe, whether it's there or it's not, and then we'll map over this, and it'll only happen if it's there, where we'll remove the element from the photos. So, index of photo, what does that look like? Well, we'll take our P and our P's, and we are just going to go ahead and carry this, and it should call it index of P in our P's. And the problem here is that JavaScript equality comparisons on objects doesn't really work very well, so we'll say the src, and we'll just go ahead and map the prop src here. So it'll find the same index in there, and this will work just fine. So once we get the index, we would like to actually return a maybe here, and I think this will be a nice reusable function. So before we go further, why don't we do a quick refactor and make a little utility module that we can put this in. And what that will give us is the ability to separate our reusable functions, and functional programming tends to lend itself to a bunch of little bitty reusable functions. So let's make a spot to put these, and then we can keep our application-specific logic separate to keep our cognitive load down and things as highly reusable. So let's go ahead and give this a signature, and we'll go make this utility module. So this takes a photo, array of photos, returned as a maybe array, maybe index, there we are, number there. So we're going to implement index of, let's go pull it in from index of, from our own little module, utils. Okay, and while we're at it, why don't we go ahead and move this HTTP and things over there. So we'll pull this in. Let's do this quickly, a nice little refactor. Okay, here we are. So what we've done here is simply move HTTP and prevent default over to our utils now that we have it to keep our application clean. Just kind of pull this out of the collage, and over here in our model, we've moved the HTTP nonsense out of here and imported it. Now, looks like we're also going to need to bring in curry over here, but that's the point. Okay, now, let's actually write our index of function over here. So what does index of look like? Well, it's going to be a function, right, from an array of A's with an A and an array of A's to a maybe number. And to do that, we're going to curry this, taking our X and X's. It's kind of conventional to use A in the type signature, but X in the actual implementation kind of separates the two things. Now, we can say const idx is just the X's index of X. And then we'll do our one and only comparison here to say if the idx is less than 0, we will return nothing. Otherwise, we'll return just idx, and that will give us the ability to later map and never have to worry about if-else and number comparisons and things like this. Let's go ahead and bring in our just and nothing from folktale data.maybe, and here we're able to use this in our model down here to get a maybe number. So we get our maybe number out, and we map over that, and it will pass the index in. We can actually write this a little bit different. We can say I, and put our I here. So we'll see that we get the index, and we remove the index here. And if that works, we will go ahead and append the photo onto that array. Otherwise, we want to append the photo onto the original array. And to get this otherwise, if it's a success, if it's a just, we want to append the photo. And if it's a nothing, we don't. We can use the concept of a fold. Does anybody here know what a fold is? Well, I suppose we better review that then. Well, we can't talk folds without starting with catamorphisms, or catamorphisms for catastrophe. It's an mnemonic device. Let's think of it as a destructuring action. Now, if we have a maybe of Emilio Estevez, we can pattern match on each of its constructors and give it a corresponding function with the arity of the property inside. That is, just has one value inside it, so that's the argument to the function, whereas nothing has no value and it gets no argument. Now, with the left or either type, we can give it a right or a left, and they both hold a value, so they both get an argument, and we can interpret this structure to get a 0 or divide by 2. And we can do the same thing with a linked list. We have a cons element onto the rest of the list, so its function here takes 2 arguments, x an accumulator, and our nil takes a 0, and this will sum the list. So a more concise way to write this is with a fold, and the exact same thing that would go into the catamorphism goes into the fold function, and we just take the just and the nothing function and concisely interpret the value. Now, with the either, we can do the exact same thing with the fold, and with the linked list, we can do the exact same thing with the fold, and this looks very much like our reduce function for sum, and that is no coincidence. Okay, now that we know what a fold is, let's go ahead and use one here to partially apply append. So if it's just, it will append this p onto that new array. Otherwise, we will push the p onto the p's and call that a day. So we'll replace or update the photo and unboxing along the way so we don't end up with a maybe. Okay, this is good. We need to bring in a few things from Ramda. So we need append and remove, and we also need fold from, I'm going to use point free fantasy here. Okay, we've got our folds and all that. Now let's go ahead and give ourselves some space here. It's hard to read a long composition like this in one line like that, so break it out into a few lines, and you see how this will never do. We have to partially apply our index of photo with our photo, and call the entire composition with our array of photos, passes it in here to index photo, passes the index in, and we fold it down, appending the p, or originally adding it here. Okay, let's give this a whirl. So if we search for a nice snowy egret, it brings in a nice amount of these beautiful snowy egrets. And don't worry about this iterator key uniqueness mumbo jumbo. We can fix that later if we choose. Let's bring this down here, and it says, oh, x.fold is not a function. And indeed it isn't. So if we look at the maybe type from Folktale, it does not have a mention of fold, we see, except for the either. Now, this will only work on a different type. It doesn't work on maybe. We don't have a fold here. But what we can do is use the option type from Fantasyland. So we've got fantasy options. And indeed here you can see there is a fold right at the top there. It's got a fold function, and it's implemented here via catamorphism. And this type is very much like a maybe. It has a corresponding sum to the just and none to the nothing, although none is a singleton here, not a function. So we can use this information to convert a maybe to an option and fold that down. And this is a useful technique. So let's go ahead and write this function, const may to opt. And this will take a maybe, and just use our catamorphism here to take just to sum and nothing to, it's not a function, so we have to make one, and to none. There we are. Complete that. And the type of may to opt is an important one. It takes a maybe A to an option A. And this type tells us it's a natural transformation. Do you all know what a natural transformation is?
Not sure.
Right, so let's look at that really quick. A natural transformation takes some f of a to a g of a. That is, some functor with an a in it to some other functor with the same a in it. So if we have a maybe a to an array a, or an array a to a stream a, or a stream to an observable, you get the point. So if we have an array to maybe, how will we do this? Well, we can pull the head off and put it right into a maybe using from nullable, which will choose just or nothing for us. Or going the other way, we can take a maybe to an array by folding it down, interpreting this just into a singleton array of x, or the empty array in the case of nothing. Now note this is not an isomorphism, because we would lose all the other elements in the array going from the array to the maybe. So more formally, all the functions that satisfy this equation, map f, then do the natural transformation, should be equal to doing the natural transformation, then mapping f. So looking at this, we can increment every value in an array, then turn it into a just or a maybe, and from there we can do the other thing. We could turn it into a maybe first, then increment the value inside. And in JavaScript, this happens to be a useful optimization. And knowing the equation, we know it doesn't matter whether the array to maybe or the natural transformation is on the left or right side of the map. It will always be the same result. Now, looking at this type signature, f of a to g of a, we know nothing of the a. We can't actually touch the elements inside of the functor. So it's not just a type transformation, it is actually the natural transformation, or a structural related function. So you see, this is a functor a to another functor a. It does not touch the elements at all. It is the type of a natural transformation, and that tells us may to opt can be used here, right above the map, may to opt, or we can choose to put it below the map. And we know because of the properties and laws that that will always hold. I like it above because it is more self-explanatory that we are transforming it for the fold. And incidentally, can anybody tell me if I had an opt to may, which we can certainly write, that would change an option to a maybe a, what that would be?
An isomorphism.
That is correct, an isomorphism. Okay, let's not bother because it's not really being used here. But let's go ahead and try this out. So, search for a lioness, bring it in, and we'll move our lioness down here. Oh, sum is not defined. We've got to bring in sum and none from fantasy options. Yeah, I'll just do fantasy options. And let's try that again. There it is. It brings these types in like this. We can bring in the lioness, and does it move? Sure enough, it moves. So we can bring in new images and move them around just like that. Very nice. Okay, that sums up today's class. Next time we'll be making a server with validations, going into monads and traverses, and all sorts of things like databases. I hope to see you next time. Thanks for attending class.